Cambridge AS Computer Science, Chapter 1, Information Representation, Part 3. We start from internal coding of images. You should have studied that a picture consists of pixels. That was in the O-level computer science. A picture consists of pixels. However, in the AS, I need to represent to you another way of storing an image. Okay, so a bitmap graphics consists of pixels. What is a pixel? A pixel is a picture element, the smallest element of an image. When you picture a garden or a tree or a flower, the image consists of pixels. However, because pixels are so small and so many, you cannot see individual pixels. Because if a picture is taken at the resolution of, for example, 10 megapixels, so you have 10 million elements on the screen, you just cannot see individual elements. What you have here is an extremely enlarged picture where the pixels appear as they really are. They are squares. Okay? However, so that was on the O level. Here in the AS, we have another way of representing images, and that is called vector graphics. Okay? So images can be stored in a computer system for eventual purpose of displaying the image on the screen or printing it on paper. Okay, so we have two ways of representing images. The first one, the new one I need to present for you, is vector graphics. Okay, let me play drawing images in front of you so you get an understanding, or you can see exactly what I want to say rather than saying millions of words. Okay, let me go directly to an empty Word file. Okay, I will start inserting shapes simply because a vector graphics image consists of shapes. Okay, I have here the menu insert. I can, for example, insert a rectangle. So I draw a rectangle. Okay, what do you think is stored now? What is stored now is not pixels. What is stored now is the name of the shape, is the properties of the shape. And this is what I mean by vector graphics. So the shape I have in front of me now is a square or a rectangle. It's a rectangle. Okay. So what is stored now is the name of the shape. It's a rectangle. What are the properties of that rectangle? It's the width and height of that rectangle and the border thickness. I can alter border thickness. For example, I can make it that thick, or I can change the shape fill. I can make it filled like that. So now what is stored is the shape properties. The shape properties. Okay, let me put another shape. For example, this would be this would be a circle or an oval. Let us make it a circle. Again, what is stored now is another shape that is a circle, with the properties of the circle is the radius and the position of that shape regarding that other shape. And then I can change the properties and I can fill it. This is the border, the shape outline, and the shape fill. Okay, okay, this is what I mean by vector graphics. Vector graphics originate because you are drawing a geometric shape. For example, you are doing a design of a building or the design of an engine. So you are dealing with geometric shapes. So they said, okay, we can store it as a list of geometric shapes. When an image is stored as a list of geometric shapes, we call it vector graphics. And then it has so many benefits, and also it has so many disadvantages. We will discuss them because this is our syllabus. For example, you can move shapes relative to each other. Or you can group them. For example, you can select them all and right click, and then you can group them. I'm not selecting them properly, so I cannot have. So these are the shapes, and then I can group them. Now they are grouped together in a single drawing. However, inside that drawing, you have shapes, you have geometric shapes. And the beauty of that is that you can rescale without distortion. You can reduce or you can enlarge without being distorted, because a pixel, a bitmap image that consists of pixels, when you enlarge it, it pixelates. The pixels become obvious and the quality is reduced. As you can see here, this is such an enlarged image. Okay, and also this is a picture taken at a low resolution, and when you enlarge it, it becomes really ugly, rather than a picture taken at a high resolution. These kind of effects are only a property of a bitmap image. A bitmap image consists of pixels. However, with vector graphics, you can group together, you can enlarge, you can reduce the size without any loss of quality. However, in order, let me try to recall all the drawbacks of vector graphics, and then I go and read my notes and tell you everything in details. Okay. However, in order for that image to be displayed on the screen, it requires a lot of processing, because it can only be displayed on the computer screen when it is converted back to pixels, because the screen is only made of pixels. Okay, so a vector graphic requires a lot of processing. It is stored as graphics and as a list of shapes. However, when displayed, it has to be rendered, it has to be changed into pixels to be displayed on the screen, and this involves a lot of processing. Okay, okay, okay. Now you have an idea what I want to say. This is a shape, this is a circle, and this is a rectangle, and these are also rectangles. Okay, fonts, text is stored, they call it true type font. So these are stored in the form of equations representing circles and rectangles, a list of shapes. This is what I want to say about vector graphics. Let me go back to the notes and read everything. Hopefully, everything will be clear for you. So vector graphics store a set of instructions about how to draw a shape. This should be clear for you, because I spend some times playing with Microsoft Word and drawing shapes. Okay? Okay. It is normal for an image that is created by a drawing package or a computer-aided design package, CAD. CAD is about creating engineering drawings. Okay? To consist of a number of geometric shapes. You have seen. You have seen geometric shapes I have been drawing. The image is then stored as a vector graphics file. Okay? Vector graphics can be enlarged without the image becoming pixelated. This is a drawback in bitmap image. When you enlarge a bitmap image, it pixelates. And this is what I meant by pixelating. It is distorted. Okay. However, with a vector graphics, you can enlarge it, you can reduce it the way you wish, and it's not going to be a problem. Okay. Okay. Vector graphics can be enlarged without the image becoming pixelated. Vector graphics are suitable for geometric shapes. Individual elements of a vector graphic can be grouped. I showed you that. However, vector graphics need to be rasterized. What is meant by rasterized? Converted into pixels. Why do I need to convert it into pixel? Be displayed on a screen or sent to a printer. Okay, so it needs to be rasterized in order to be displayed, or printer. In vector graphics file, we have attributes. What is stored is just attributes, not pixels. Okay, such as drawing objects, properties, and drawing list. Okay, contents of a vector graphic. Please go and study this very well. Why? Because all of these are answers to exam questions for the AS computer science. Okay, this is what have been in the exams. This is what have shown in the exam. I'm presenting this for you so that you can understand it. Contents of a vector graphic image. There was an exam that asked you to list the contents of a vector graphic image. It contains a drawing list. As you can see, I think this is a repetition of my explanation. And this proves that I'm teaching you things that show in the exam. Okay? It is a series of geometric shapes, lines, and objects. Stores coordinates, the XY coordinates of every shape. Store commands and formulae, the formula for drawing a circle, the formula for drawing a straight line. These are the information stored in a vector graphics for creating each individual object and the attributes and properties of that object. For example, color, thickness of line, etc. Okay, what are the advantages of using vector graphics? Definitely compared to bitmap graphics. So these advantages and disadvantages are compared to bitmap graphics. I don't need to say this. Okay, the image can be enlarged without becoming pixelated because in a bitmap graphics image, when you enlarge a picture, it may pixelate. Okay, because why it doesn't pixelate in the vector graphic? Because the instruction to create the image are stored. You don't store pixels, you store instructions to draw an image, and when you enlarge it, you reapply the same instruction, the same equation, and draw it on a larger scale without any pixelation. Usually smaller file size, an image stored as vector graphics takes less space than an image stored as a bitmap graphics. Usually smaller file size because only coordinates and calculations are stored instead of individual pixels. Individual pixels take a lot of size stored. Disadvantage, vector graphics require more processing power. Why? As the image needs to be rasterized. What is meant by rasterized? Converted into pixels in order to be displayed or printed. See, it is just what I have been teaching you a few minutes ago. Okay, let us now go to the traditional thing that is the bitmap graphics that consist of pixels. The bitmap graphic. The fundamental concept underlying the creation of a bitmap file is that picture element, that is the pixel. Okay, the pixel is the smallest identifiable component of a bitmap image because pixel stands for picture element. The image is stored as a two-dimensional matrix of pixel, X and Y. Bitmap is made up of pixels. Forgive me because some sentences are repeated. Bitmap files are usually bigger than vector graphic file and take up more memory space. Enlarging a bitmap means the bitmap image is pixelated. Okay? Okay. Okay, so this is a picture. This is an example of a picture taken at a low resolution and then enlarged. As you can see, distortion appears. We call this pixelation. Rather than being stored at a high resolution from the beginning, and then there are no degradation of quality. Bitmap image can be compressed. Eventually I need to teach you about lossy compression and lossless compression. And this is exactly as it has been taught in the O-level. Lossy compression, lossless compression. Sometimes I need to compress an image. Why? Because it consists of pixels and it takes the image size goes very large. So I need, for example, to send it as an email attachment, and email attachments only have limited file size. Okay, so maybe you need to compress. There are two ways of compression: lossy compression and lossless compression. With lossy compression, you discard some of the quality of the image because we call it lossy. We discard some pixels, or we discard some color definition. We will talk about color definition very soon. So the quality of the image is little bit reduced. Hopefully the file size will be greatly reduced. Okay, this is called lossy compression. We rely on the fact that the eye cannot see everything. So with images, we may do lossy compression. With audio, we may do lossy compression because the human ear cannot hear everything, is not perfect. However, if you have some data files and you would like to compress some data file that has to be exact, you would like to compress and reduce its size, you only can do lossless compression. With lossless compression, as the name implies, nothing of the data is removed. However, for somehow, that is, we need to clarify, somehow the file size is reduced. Somehow. Okay? Okay. We will talk about compression later on. Hopefully today, if we still have time. If we cannot have time, we will defer it to later. Okay? So we talk about compression with images. Okay, bitmap images can be compressed with significant reduction in the file size. Bitmap images are suitable for photographs and scanned images. Bitmap graphics use less processing power than vector graphics. Individual elements in a bitmap cannot be grouped. Okay, now we have a very thorough comparison between vector graphics and bitmap image. Okay, let me talk about bit depth. What is meant by bit depth? The bit depth of a bitmap image, these are all properties of bitmap images, is the number of bits that can be used to store a pixel. So first, if you'd like to estimate the file size of a bitmap graphics, and this is on exams since the O-level age. Okay, so you need to count how many pixels wide and how many pixels high, and this is the number of pixels multiplied by how many bits for each pixel. Then you may estimate the file size. Still, you may need to add the header data, estimation of file size. You may also need to add the header data, but we do not consider this right now. Okay, so let us now focus on the bit depth. What is the bit depth? The number of bits used to represent a pixel. What is the effect of having a larger or a smaller number of bits representing a picture? It directly affects the number of colors. The number of bits to store a pixel directly affects the number of colors that could be represented. If you only have one bit to represent a pixel, then that one bit could be just a 1 or a 0. Then the colors would be just a black and a white. And the relationship that links, that you have to study this. Okay, this wasn't in the AS, in the O level. This hasn't been in the A level, in the AS, in the O level, I'm sorry. Okay, so when you have one bit, the relation is 2 to the power of n. When you have only one bit, 2 to the power of 1 is 2. Then you can only have two colors. Probably those two colors would be black and white. If you have, for example, 4 bits, 2 to the power of 4 is 16 colors. When you have 5 bits, 2 to the power of 5 is 32 colors. You should know very well the powers of 2. You should know there are no calculators in the exam. You should know very well the powers of 2. For example, I know very well 2 to the power of 10 is 1024. I know very well that 2 to the power of 8 is 256, because when you have 8 bits, the biggest value that can be is 2 to the power of 8 minus 1. Okay, that 2 to the power of is with us everywhere. Okay, is with the, we have been using this. We use that with the when we were discussing ASCII. I have 8 bits, 2 to the power of 8. You have 256 different colors. When you have 16 bits, 2 to the power of 16, you have 65,536. I am telling all these from my memory. Why? Because this is what is supposed to have. This is what is supposed from, what is expected from a computer engineer. This subject is teaching you to become a computer scientist. Computer scientists can see or evaluate these values orally, mentally. Okay? Because in the exam, I will show you an example right now. Okay? You have to have these on your mind, or at least you can figure them out or compute them rapidly. Okay? So the color depth, this is a table of popular color depth. Why do I have to teach this? Because that was once in an exam. And it said, what is the minimum number of colors? And what is the maximum number of colors? And what is the minimum number of bits? That was the question, and that was the answer. So if you have 68 colors, if you have 68, let us go here. You need 68. 64 is 6 bits. Okay. Think of 7 bits. Think of 7 bits. If it is just greater than 64 by 1, if it is 65, you cannot use 6 bits, use 7 bits. So you have 68 colors. If it has been 64, it would be just 6 bits, but it's a little bit more than 64. Okay, try the 7 bits. Okay, you have 256. Yeah, 256 goes perfectly into 8 bits. So you have 256, use 8 bits. You have 127. Maybe I need to put here. I put here 8 bits. Maybe I need to put here. Maybe I need to put here 7 bits. You do that. You have to, because you're not supposed to memorize everything. You have to be able to explore this in the exam. So 2 to the power of 7. What do you think? Is twice that. 2 to the power of 7 is twice that. So it is 128. Okay? So you need here 127. Okay, 127. Okay, 107 bits can go with you up to 128 colors. Okay. So again, use 7 bits. So 7 bits is used for 127. 7 bits is used for 68. However, with 68, there is a little bit of waste, but you cannot save that. You have 2 bits. You have 2 colors. Okay, you use 1 bit. 2 to the power of 1 is 2. It is just a 0 or 1. It is very obvious. You have 249. 249, go back to the table, and you need to be, maybe you memorize the table, or maybe you need to be able to recreate it in the exam, or just try to solve it the way you wish. 8 bits is enough, because I know for sure that 2 to the power of 8 is 256. Okay? Okay. So you need to be able to solve that kind of question, because they are relating between the bit depth, which is the number of bits for a pixel, and the number of different colors that can be represented in that pixel. Okay? Okay, let us go to another example. I'm bringing exam papers into my notes. Okay, just to train you. Later on, we will go to the classified and do some exercise. So what is meant by a pixel? This is the smallest identifiable component of an image. What is bit depth? The number of bits used to represent each color. What is image resolution? The number of pixels wide by number of pixels high. What is file header? We didn't talk about this. After we do all this estimation of file size, I will tell you there is also what is called file header. Let us read it right now. This is extra information stored in the image file besides the pixels. Okay? The file header stores information about image size, number of colors, and store about parameters of the image, and other data need to display an image. Metadata. This is metadata. The header contains metadata. Metadata about the image is stored in the header of the file. So the header file stores metadata. The header file will contain the following information: confirmation of file size, whether it's JPEG or JPG or PNG, the file size, dimensions, width and height, color depth, which is number of bits per pixel, 1 or 2 bit per pixel, the type of compression, if any, lossy compression, lossless compression, or whatever. Okay, so this is what will be in the file header. Okay, our image resolution, see, they have so many definitions. Image resolution is measured in dot per inch. This value determines the amount of details in image. Screen resolution. So the image resolution is the image. The screen resolution is the resolution of the computer screen itself. They look very similar. Is the value quoted for a monitor such as 1024 by 768. This is a typical resolution for an old image, an old laptop screen. The larger the number, the more picture elements, pixels, can be displayed. Okay? Okay. Let us go back. Let us go back and discuss about estimation of bitmap file size. You should have been doing that since the O-level age. Because if they give you an image and give you the number of pixels wide and the number of pixels high, you multiply them and then you get the image resolution. And then they may be kind and give you the number of bits per pixel. Then it is direct multiplication. Or they give you the number of colors, and using the relation 2 to the power of n, you can find that n, which then will be the number of bits per pixel. Okay, so they may involve this. Let us go through all these examples, and all these examples are just taken from AS exams. Okay, let us go through this, and please practice and know how to do the calculations by hand without touching a calculator. Why? Because you're not allowed to use a calculator in the exam. Okay, consider that a bitmap file, let us go and do this example. Consider that a bit file is needed to fill a laptop screen where the resolution is 1366 by 768. Probably you will multiply these and get the number of pixels. Easy. If the color depth, which is the number of bits per pixel, okay, 24. Excellent. Thank you. Is not giving me the number of colors. Is giving me the number of bits. Thank you. I don't have to go to that 2 to the power of n thing. Thank you. Okay, so actually what I have here is 1366 multiplied by 768 multiplied by 24. As file size is always quoted as a number of bytes. This is bits. This is 24 is in bits. Maybe you need to divide it by 8, okay? Because a byte is 8 bits. Okay? Number of bytes. Okay? Or number of maybe byte. Maybe byte. Okay? Maybe Maybe is 1024 multiplied by 1024. Okay, so you divide it by 8 and you divide it by when you divide by 1024, it becomes kibi. When you divide by 1024 again, kibi becomes mibi. Okay, okay, so how would you do that without a calculator? First, try to take this with that and become here 3. Try to play with powers, or just give, or if you are really helpless, okay, consider that 1024 approximately 1000. In that particular exam, they were allowing you to do an approximation. It is around 3 megabytes. Okay, if you put the equation, if that question is worth 3 marks, if you put the equation, you get 2 marks. If you are able to reach the final answer, you get the full 3 marks. Okay, just put the equation, and then if you have plenty of time, fight for it until you get the final answer. Okay, let us go to another example. I hope that other example would be easier. A black and white image. Oh, a black and white image. How can you use this information to find the number of bits per pixel? Black and white, you only need 1 bit. That would be either a 0 or a 1 to represent the black or the white, because the rule says 2 to the power of n equal the number of colors, and number of colors is 2. So 2 to the power of 1 is 2. You need 1 pixel. I'm sorry, you need 1 bit. Okay, from this, you can see that the number of bits per pixel is just 1. Okay, so a black and white image. Okay, then the number of bits is 1. Is 512 by 256. Multiply this by that. The file size of this image in KB, when the exam says KB, then it is 1024. 1 KB is equal 1024 bytes. Okay, so the equation should be 512 multiplied by 256 multiplied by 1. And it has to be divided by 8 because you don't want it in bits. You want it in bytes. Okay, so you divide by 8. And also you divide by 1024. How can you do that? You have to be able to notice that twice of 512 is 1024. So this and that can go and become 2. So 8 multiplied by 2 is here. This is gone, and this is gone. It is just 1. So it is 256 divided by 16. You should also know from hexadecimal that 16 squared is 256. So the result is 16 KB. Okay, no calculators here. No calculators are used. Okay, next, an image has 160 pixels wide and 160 pixels high. Okay, we will multiply these. The image has color depth of 3 bytes. Excellent. It's not giving me the number of colors. It's giving me the number of bytes. I don't even have to divide by 8. Because when it is 3 bytes, here it was 24 bits divided by 8, so it is 3 bytes. Here is given as 3 bytes. Given as 3 bytes. You don't need to divide by 8. Okay? An estimation of the file size in KB. KB is 1024. Kilo is 1000. And that is now in the O level. Used to be in the AS, but now it is now in the O level. Okay? So the equation should be 160 by 160 multiplied by 3 divided by 1024. Maybe you can recall that 1024 is 2 to the power of 10. You should know that. By practicing, you don't have to go and memorize, but by practicing. A kibi is 2 to the power of 10. That is 1024. And then this is 2 to the power of 4 multiplied by 10. And this 160 is 2 to the power of 4 multiplied by 10. And the other 160 is 2 to the power of 4 multiplied by 110. Okay, you can subtract powers. You have 2 to the power of 10 below, and you have 2 to the power of 8 above. Subtract powers. You end up with 2 to the power of 2 below, and that is 4. At the top, you have 300. 300 divided by 4 is 750 kibi. So I'm not here only teaching you computer science. I'm also teaching you arithmetic or mathematics, the way you wish. Okay? Example. Another example. See, we have plenty of examples. Maybe these are all the examples that have been in the past papers. Okay, let us go a little bit faster. A digital camera takes a bitmap image. The image is 2000 pixel wide by 1000 pixel high with a color depth of 24 bits. Okay, so the color depth is given in bits, not in number of colors. Excellent. An estimate of the file size of the image in megabytes. An estimate of the file size in image in megabytes. When it says mega, divide by 1000, no problem. Mega is divide by 1 million, no problem. A kilo is 1000. A kibi is 1024. Okay? Okay. So if you do it in megabytes, you divide by 1000. If you do it in megabytes, you divide by 1024. If the exam is allowing you, look for which one is easier with numbers. I think here, mega 1000 by 1000, because these will go with that, remaining 2. So it will be 2 by an 8 and 3, become 8 and 24, remainder 3. So it is 2 by 3 divided by 1, and it is 6 maybe. This is 6 megabytes. Okay, and here it is in megabytes. If you insist of dividing on 1024. Okay, I will leave these for you to study because I need to go ahead. A picture has a width 8192, a height 256, 256 color. Okay, you are provided with the number of colors. And this implies that it is 8 bits because 2 to the power of 8 is 256 colors. Okay, and you should know how to do. It uses the next question. It uses 35 different colors. There is nothing 35. I know the 32 and then the 64. This is 35. Consider it 64. When it is 64, you need 6 bits because 2 to the power of 6 is 64. You cannot do with 32 because you need 35. From 35 till 64, the rest is a waste. Okay, I don't mind. So see how ideas come in the exam. Okay, so we have 35 colors. 2 to the power of 6 is 64. We cannot use 2 to the power of 4 because it is 32. Okay, okay. I can also say that here is 32 and here to the power of 5. Okay, so you just put this in your discussion. Okay, to the power of 5 is 32, is not enough because you need 35. To the power of 6 is 64. Okay, the rest is waste, and then you go through the calculation. Okay, we did file header, we did image resolution. Do you think we can go through? Maybe we can do internal encoding of sound, and then compression, that is lossy and lossless, and then the chapter ends. Okay, I don't think I can do that right now. Okay, I will stop here and then go to the classified and do some examples instead. Please go to my classified page 27. This question is taken from 21 November, paper 1-2. The question said, somebody has created the following logo as a vector graphic. So this is an example of a vector graphic. Complete the table by writing a description of each vector graphic term and give an example. What is meant by a property? What is meant by a property in vector graphics? And give me an example. What is meant by a drawing list in vector graphics? And give me an example. So see, they are asking you about details of a vector graphics. Okay, what should you say? Let us look at the answer. This is the mark scheme. Please study this with me. The property is data about the shapes. Definition of one aspect of the appearance of the drawing object. For example, a black line. You give me examples. Give me examples from the drawing here. Example of property: black line, white fill or black fill, solid line, front of letter, color of triangle. These are all properties of vector graphics, and these properties are here in that vector graphic image. Okay? Okay. What is a drawing list? Is the list of shapes involved in an image, or it's a list that stores the command description required to draw each object. Example of list of shapes here: I have a triangle, I have a capital letter R, I have a rectangle, I have a line. Please copy this in your classified. Let us go to the next question. Somebody takes a photograph using a digital camera. The photograph is stored as a bitmap image. Describe two differences between a vector graphic and a bitmap image. This is a list of comparison. Bitmap is made of pixel. Bitmap was made of color stored for individual pixels. However, vector graphics store a set of instructions about how to draw the shape. When bitmap is enlarged, pixels get bigger and it pixelates. When vector is enlarged, it is recalculated and does not pixelate. Bitmap files are usually bigger than vector graphic files because of the need to store data about each pixel. Vector graphic have a smaller file size because they contain just the instructions to create the shapes. Bitmap images can be compressed with significant reduction in the file size. Vector graphics does not compress well because of little redundant data. The vector graphic is already small by itself and doesn't need any further compression. Okay, Shabab, give yourself time and study this. Going through past papers and going through mark schemes provides you with additional information to what is being taught in my lesson and from my notes. You need that additional information because I would like your knowledge to be rich. And unfortunately, I cannot copy everything in my notes. Otherwise, it's become very big. Please give yourself time to study and copy this.